Welcome everyone, my name is Satyajeet Sahu and in this 2020 series, today we are going to solve questions from Irrigation Engineering. Okay, so in Irrigation Engineering, the most important topic I can say for your GATE exam is what? It is the water requirement of crops. It is what? It is the water requirement of crops. So, today mostly we'll be solving questions from your water requirement of crops. So welcome Swapnil, very good evening, and other participants, and also warm welcome to all the participants who are seeing this lecture recorded. Okay, so warm welcome to everyone. So we'll be solving questions from mostly water requirement of crops and some questions from canal design. Okay, so let's start the session without any further delay. So first of all, a short introduction about myself. My name is Satyajeet Sahu. I have 10 plus years of experience in GATE and ESE. I have done my BTech and MTech from IIT Kharagpur, and some other credentials are also mentioned. You can go through them. Yes, I have been teaching in this field for more than 10 years and in more than 15 states. Okay, and I have been associated with BYJU'S for the last 2 years. So let's start the session. Okay, good evening, Juhi. So here comes the first question, but before the first question, let me just revise some of the formulas which will be useful in this particular session. Let me first revise some of the formulas which will be useful. Yes. Now in soil, we know that there is something known as what? There is something known as your field capacity, right? In the soil, we know that there is something known as your field capacity. Yes. And there is a permanent wilting point. There are two moisture levels, I can say. These are two moisture levels. One is what? One is your field capacity. This is what? Your field capacity. Yes. And the next one is what? It is your permanent wilting point. It is what? It is your permanent wilting point. Yes. Or wilting point. In short, we call that as PWP, yes, and this field capacity is known as what? FC. So welcome Lakshmi, Nikki, Saurabh, Sri, Nitraj, Samriddhi and Naivedya. Warm welcome to everyone. Yes. Now, the storage capacity is this one, right? This depth is known as what? The storage capacity. And how we find out this storage capacity? Or I can say maximum moisture content, maximum available moisture or storage capacity, or I call this as what? Your storage capacity. Okay, also known as what? Your storage capacity. How we find this? This is gamma D by gamma W, the dry unit weight of the soil divided by unit weight of water. Then the D is what? Depth of root zone. Then what? Your field capacity minus permanent wilting point. Field capacity and then permanent wilting point. This is what? This is the available moisture. Available moisture. Now, if the moisture is the maximum available moisture, so if the moisture is somewhere here, yes, the moisture level is somewhere here. This is suppose M, moisture level, current moisture level I can say. If this is the current moisture level, then I can say that this much irrigation has to be done to increase the moisture level from current moisture level to the field capacity, because we don't irrigate the soil beyond the field capacity. Why? Because if you irrigate the soil below, above the field capacity, that will be what? Wastage, that will drain out, right? So I can say this is what? This is the irrigation depth. This is the irrigation depth. And how we find out this irrigation depth? I can say this irrigation depth will be, you see, when I was finding this one, how I found out? How I find out? Gamma D by gamma W. D is depth of root zone into what? F minus P. So similarly, this will be what? Gamma D by gamma W into D, and then what? Your F minus M. So this is the way we find out what? The irrigation depth or depth of irrigation. And this is what? This is your maximum available moisture. Understood? Using these concepts, the small concept, to solve some questions. So this is a question. Irrigation water is to be provided to a crop in a field to bring the moisture content of the soil from existing 14.5 to the field capacity of 28%. Simple, straightforward question. We'll start with straightforward question, then we'll go to the complicated ones, right? The effective root zone is 90 centimeter. Yes. The densities of the soil, gamma D, and water, gamma W, are also given. Okay. They're asking you the depth of irrigation. Okay. So very straightforward question. Please solve this. Depth of irrigation. Depth of irrigation. Please solve this. Depth of irrigation. Okay. So it is what? Simply gamma D by gamma W. Okay. Then your depth of root zone. Then F minus your moisture content. And whenever you are mentioning this F and M, that should be in what? That should be in decimal. So please solve this question. I will wait for your answers. Please solve this. The formula is there. The equations are there. Please solve this. Please solve and write in the comment section. Okay, then I can, proceed. (187). Okay, very good. So this is what? 1.54 divided by 1 into D is given how much? It is given in centimeter, but the depth of irrigation is asked in mm. So what I will do? Into 900 centimeter, 90 centimeters to 900 mm. Then you express this in what? In decimal. Yes. So when I'm using this, let us see what I'm getting. So 0.28 minus 0.145 into 900 into 1.54. I'm getting a value of 187.11. 187.11 mm. So this is a very straightforward question. It's a very straightforward question. Let us complicate the things. Let us complicate the things. We'll introduce this concept of what? Water application efficiency. Now what is water application efficiency? It is given this rotation, and this is the water stored in root zone. It is the water stored in root zone divided by water to be provided. Water to be provided. Yes. Yes. I can say this water to be provided is the, we can say, applied irrigation depth, right? I can say this as what? The applied irrigation depth. Yes. And this is water stored in the root zone. Means how much water is required actually to bring the moisture content from the current moisture content to field capacity. So this is actually the depth of irrigation. The depth of irrigation. Yes. And how we find out this depth of irrigation? This we find out using the formula gamma D by gamma W, D into F minus M. Right? This we get. Now if they ask you, they give you this water application efficiency, and they ask you the water depth required to be applied in the field, then can I say this from this formula? The applied depth will be equal to, what? The depth of irrigation which you are getting from the calculation. The depth of irrigation which you are getting from the calculation divided by what? Divided by the water application efficiency, and that I will express in what? Decimal. Okay. Some students also find out the answer. So now using this information, please solve this and give me the applied depth of irrigation. In this information, give me the applied depth of irrigation. Please give me. Please give me. Good evening. So you see field capacity is given and wilting coefficient, or you can say permanent wilting point is given. The dry unit weight is this, okay, and depth of root zone is this. Irrigation water is to be applied when the water contents falls to 16%. That means what? You see, this is your field capacity. This is your permanent wilting point, right? So this is your 29% and this is your 13%. Yes. So when we are doing the irrigation, when the moisture content is falling to how much? To 16%. Then I am doing this particular irrigation. Yes. So from here you can find out what? This is the depth of irrigation, right? This is the depth of irrigation. The depth of irrigation, okay. Now I found out answer. Okay, many students have found out. Okay, this depth of irrigation, suppose I'm asking the depth of irrigation in mm. This depth of irrigation will have this formula. What? Gamma D, that is how much? Gamma D is how much? 1.45. My gamma W is obviously 1, you should know. Depth of root zone is 76 centimeters, so I'll express in mm, converting into mm. And then, this is the field capacity and the moisture content is how much? 0.16. So if you find out depth of irrigation, first of all, when you find out depth of irrigation, how much are you getting? If you are finding depth of irrigation, you will be getting a value of 143.26, right? This you are getting is 143.26 mm. Everybody is getting this? This is what? 146.26. 143.26 we are getting. But it is asked what? Applied depth. It is asked what? Applied depth. So applied depth will be what? The depth of irrigation divided by what? The water application efficiency, that is how much? 0.75. So when you divide by 0.75, we get how much? Almost I can say 191 I get. Almost I'm getting how much? 191. Understood? Now in the previous question, they have not given, you see, I will just switch it off. Mobile is doing cuckoo. Okay. So, in the previous question, you see there was no mention of water application efficiency. So when that is not mentioned, you can take what? Water application efficiency as 100%, or in the calculation you can take what? 1. It was not given, if not mentioned. If not mentioned in the question, then you can do this. Okay. Let us solve another question. Next question is, yes, the consumptive use of water for a crop during a particular stage is what? 2 mm per day. Okay, this is what? The water requirement per day. Okay. The maximum depth of available water in the root zone is 60 mm. That means what? You see, this is your field capacity, this is your permanent wilting point. And what I told, this will be, what I told, this is the maximum available moisture, right? That is given how much? This is given at least 60 mm. Then some information is given. Irrigation is required when the amount of available water is 60% of maximum water. Okay, they're asking you the frequency of irrigation. Now, how to find out frequency of irrigation? Frequency of irrigation is very easy. Frequency of irrigation is the depth of irrigation divided by what? Depth of irrigation divided by daily consumptive use of the crop. It is what? Nothing but the depth of irrigation divided by what? The daily use or daily consumptive use of the particular crop. Now, can you find out depth of irrigation from the given information and find out this answer? Come on, first you try, then I will solve. First you try, then I will also solve. Come on, you try first. Read the question carefully and try to solve it first, and then I will solve for you. Come on. $18 days, you are telling 18 days, okay, the others, okay, 18 days, okay. Let us read this line carefully. Irrigation is required when the amount of available water is 60% of maximum available water. Now see, if this is the moisture content, suppose I am telling this is the moisture content. This is the moisture content, M, right? So if this is the moisture content now, then this is the available moisture, right? Yes or no? This is the available moisture. What is this one? This one is the maximum available moisture, right? This is what? This is the maximum available moisture. This is the maximum available moisture. And this is what? The available moisture. And this available moisture is given what? It is writing that, it is written that this is 60% of the maximum one. So this is 36 mm na. This is 36 mm na. This is 60%, 0.6 of 60 mm. So this is the available moisture. Yes, currently. So how much irrigation you will do? You will do this much irrigation, right? So to bring the moisture content from the current moisture content to the field capacity, right? So I can say this is the depth of irrigation and this is how much? This is 24 mm. So the answer will be how much? Frequency will be 24 mm divided by daily use is 2 mm per day. So you can see that this mm get cancelled, this becomes 12. So the frequency of irrigation, how much I got? 12 days. Everybody understood this language? Everybody understood this language? Yes. So therefore I, use this language to confuse you. Yes. So read the question carefully. The language, some 1-2 words, if you misread or you misinterpret, then the whole answer will change. So for getting ready for your upcoming GATE examinations, it's very important that you attend such sessions where we are making you aware of such traps. Yes. So obviously we should solve the previous year questions, but along with that, it is very much required that you attend such sessions and enrich your understanding of the GATE examination and also avoid committing any kind of mistakes. Okay, thank you. Let us solve the next question. Now this question you solve, okay? So this question you solve yourself, okay? Come on. This question you solve. Read the question properly and solve it, okay? I'll wait for your answer. आराम से solve, don't no worry. Solve. 108 days. Very good. Very good. 108 days. This is centimeter, not mm. Okay. So see, this is the field capacity. This is the permanent wilting point. We are doing irrigation when the average soil moisture drops to 18. So when the moisture content is 18, we are doing the irrigation. That means what? This is the depth of irrigation. And this depth of irrigation will be how much? Gamma D by gamma W into what? Depth of root zone is 1250 mm. And then filled capacity minus the moisture content. Yes, this is the depth of irrigation. Now divided by what? Divided by what? Divided by the conjunctive use, that is 2 mm. So when you're finding, you'll get 107 point something, right? So actually you should irrigate before that, right? Yes. Actually, if it was not mentioned, how much you're getting? Actually, you're getting 107.9375, right? Yes. This many days. So you have to irrigate within these days. Yes. You have to irrigate within these days. So actual answer should have been how much? 107 or 108. Ignore this line. Suppose this line is not mentioned, then what would have been the right answer? Tell me. 107 or 108? Tell me. If this is not mentioned in this 107, na? Because see, after 107, you see, after 100, that requirement is within that 107.9375. So you cannot go to 108. Yes, so actual answer should have been 107, but it is mentioned in the question, na? So sometimes they will mention some things in the question. You have to follow that strictly. So it is written round to next integer. So if they have written means we are rounding it to next integer. That is how much? 108. So sometimes they might tell you certain things. You have to follow the instructions written there. Otherwise the answer would have been 107. Okay. So these questions are, we can say, from your field capacity and other things. Let us go to the next thing. The next thing is about duty delta and all, right? So in duty delta, okay, I will give you certain equations. What are certain equations? The first equation is that whenever you're irrigating a particular field of area A and depth delta, so this will be the volume requirement. This will be the volume requirement. Yes, area A, this is the depth of irrigation. This is the depth of irrigation, and this is what? This is the area of irrigation. This is what? Area of irrigation, right? Yes. Now this will come from a particular canal. You are providing this particular irrigation water from a canal. So the discharge of the canal is Q, and you allow the irrigation for time T. So this is also the volume. This is also the volume. Yes, this is also volume. Now in this formula we'll introduce a term, what? Your application efficiency. Because whatever discharge you are providing, all the water won't be reaching the root zone. Some will be wasted. So I can say you have to multiply what? Application efficiency. And this area of irrigation, how to find out area of irrigation? If we have a total area, this is known as what? Gross command area. This is what? Gross command area. Out of which certain area can be cultivated. Certain can be used for cultivation. That is known as what? Cultivable command area. And at a certain time you can irrigate a particular area, irrigating a particular area, suppose this. So from here I get what? Suppose this area is A. This area is A. Yes, the area which is irrigated. So we have a term known as what? Intensity of irrigation. Term known as what? Intensity of irrigation. Okay, intensity of irrigation. This term is what? This term is your water application efficiency. This term is your water application efficiency. Yes, this term is your water application efficiency, and this term is intensity of irrigation. Now intensity of irrigation is what? Intensity of irrigation is the area irrigated divided by what? Your cultivable command area. So this area of irrigation can also be written as what? You see, this can be written as what? This can be written as your intensity of irrigation into cultivable command area. So we get a beautiful relation. What is the relation? That water application efficiency into Q into T. T is the time of irrigation, so we can say the period of irrigation, right? Is equal to the area of irrigation will be what? Intensity of irrigation into the cultivable command area into the depth of irrigation. So this formula you can use a lot to solve many questions. This is one formula. Another formula we use what? To find out duty. Yes, what is duty? Duty D is equal to, I can say, 8.64 B by delta, where B is the base period in days, right? It is the base period in days. Delta is the depth of irrigation in what? In meter. And duty is the area in hectare per cubic. Now if you know the duty, yes, how to find out the discharge? The discharge will be simply what? The area to be irrigated divided by what? The duty divided by duty. Okay. Now using this relationship, let us solve some questions. So first question is this: the culturable command area CCA, yes, of a distributed canal is this much. Okay. Wheat is grown in the entire area and the intensity of irrigation is given 60%. The base period is given 25 days and the water depth is given 120. The outlet discharge, you have to find out discharge if the irrigation efficiency is this. So if such a quantity is given, then obviously we can go for the equation what? Your intensity of irrigation into the culturable command area, or cultivable or cultivable, same thing, right? Into the depth of irrigation, this will give the volume, that is equal to what? The water application efficiency or irrigation efficiency, I can say, into the discharge into what? The time, or can say the period of irrigation. Now when you're calculating this, you're putting this, you have to find out this Q now. You're finding these things. What you can do is that you can put the units in such a way that both left hand side and right hand side I get in meter cube. Okay, now solve this question and give me this Q in meter cube per second. Okay, put everything in such a way that you get in meter cube both sides. So what you do, this time you mention in seconds, this area you can convert into what? Meter square, and this depth also can convert into what? Meter. Then you can get the answer of Q in what? Meter cube per second. So do it. $112. Others? Hey, why are you taking so much of time? Huh? This is 0.6. This is 40,000 hectare. 10 to the power 4. Depth of irrigation is 120, so I can say 0.12 meter is equal to application efficiency is 0.8 into Q into time is 25 days of irrigation. So each day has 24 hours, each hour has 60 seconds, and each 60 minutes, and then each minute has 60 seconds. Huh? Why are you taking so much of time? Huh? So Q is equal to, I can say 0.6 into 40,000 10 to the power 4 into 0.12, okay, divided by 0.8, divided by 25, divided by 24, divided by 60, further divided by 60. I am getting 16.67. Huh? Why you are not able to find this answer? Huh? What is happening? Gaya. Nobody is solving. Everybody is sleeping in the class. Okay, when you wake up, write down the answer, then I will move to the next question. Why you are not able to solve this very straightforward question? What was your confusion? This time is the base period, right? Base period is what? Base period is the period of irrigation or time duration of irrigation, right? It is the time duration of irrigation. Okay. Calculation mistake. Okay. Avoid it. Okay. Very easy. Let us solve next question. Okay. Solve this question yourself then. Chalo. Solve this question yourself. Little additional data is given. You see, rainfall data is given. What to do with the rainfall data? You think and solve this question. Come on, solve this question. The rainfall data is given means what? Here the depth of irrigation will be how much? Depth of irrigation, see, requirement is 100, but 25 is done by the rain. So you will give how much? 100 minus 25. So this much will be required, yes. This is the additional thing. Rest, see, time is given, yes. The irrigation efficiency is given, right? Now the area of the land is asked. And we can see that the intensity is not given. So intensity not given, we can take what? 100%. And you see this is the discharge given. Now this discharge Q is 800 liters per day. I have to convert into meter cube. So this will become how much? 0.8 meter cube per second. Okay. So the same relationship. Efficiency into Q into time is equal to your intensity into area into depth. Now this is 100% 1 because that is not mentioned. This is 0.6, discharge is 0.8, and it is given 12 weeks. Time is given 12 weeks. 1 week has 7 days. A particular day has 24 hours. 1 hour has 60 minutes and a particular minute has 60 seconds. Right? This is equal to the area which I have to find out. The area is asked in hectare. So I'll convert into meter square by multiplying into per 4. Okay. So A into 10 to the power 4, A into 10 to the power 4 into what? Into the depth of irrigation, which is given how much? 70 centimeter. So I'll convert into meter. Everything convert into what? Meter or second. So final answer we will get in what? This side also meter cube, that's also meter cube. Yes. So from here, tell me what is A you are getting? 464. Yeah. We'll get 464. Yeah. So we'll get 400. We get 464.5 hectare. Understood? So they might ask you questions from this equation. You can use this equation and solve maximum number of questions. Now, let us solve a very straightforward question. Okay. So now when you are doing the irrigation, I told you one formula, right? That your discharge is equal to area by duty. And duty is equal to what? Duty is equal to, I can say, 8.64 B by delta. Very nice. This formula we saw. Now, when we are doing two crops, irrigation of two crops, if both the crops are in the same season, then what I have to do? I have to add their discharges, right? When both the crops are in the same season, I have to add their discharges and find out the final discharge. If they are in different season, then what I have to do? I have to find out the different discharges and take the maximum one. Okay? Because we have two seasons for our crops, Kharif and Rabi. So if both are in the same season, then I will add the discharges. If they are in different season, then I will take the maximum one. For example, in this particular question, you see wheat and gram are given, okay, and both wheat and gram are same season crops. They are same, and it is written also, grown together. And your CCA is given 3000 hectare, okay, and the intensity of irrigation of both the crops is given. For wheat it is 25%, okay, and for gram is it 30%. And the duties are also given 1500 and 450. It is asked to find out the design discharge. What I will do? I will find out the discharge for wheat by using this formula. Area, how I will find out? Area will be CCA into I. Yes. So I will find out the area. and duty is already given to us. So I can find out discharge for wheat, discharge for your gram, and then add up them to find out what the total discharge, discharge. Why I'm adding them up? Because both of them are grown together in the same season. Good evening. So please solve this question and give me the discharge value. Come on, solve this question. Solve this. First find out for wheat, right? And then for gram. So when I'm finding for wheat, I can say that for wheat it will be discharge 1, suppose, that is equal to, the area will be how much? 25% of 3000, right? That is the area to be irrigated, and its duty is 1500, right? So I can say it is 0.5, right? It is 0.5 meter cube per second, right? And when we're going for the gram, it is what? The area of irrigation will be how much? The intensity into the CCA, right? And then divide by what? 450, which is what? Which is the duty. So from here I can say I am getting this as how much? Actually 7. You can do something like this, you see. So this will be, I can say, 90 by 45, right? So I'm getting 2. So I can say that for gram I am getting 2 and for wheat I am getting 0.5. And since both are grown together, I can say this design discharge will be how much? It will be 0.5 plus 2, making it how much? 2.5 meter cube per second. Yes, easy, straightforward, okay? Now suppose there is another question, okay? You see this question. Okay, so solve this question. Solve this question. Please tell me the answer to this. Read the question and answer very calmly. Aram se. Aram. And design discharge obviously going to find in meter cube per second. Solve this. Now see, the both crops are of different season. They are mentioned different season, right? So you have to find out for Rabi season and find out for Kharif season and take the maximum one, right? We added it, Vivek, they are on different season. Different season means what you will do? You will take the maximum one, right? Different season means to take the maximum one, right? Yes. Don't add, I just told that there are different season, it is written also. For Rabi and Kharif are adding. See, GCA is 5000, out of which 80% is culturable. So I can say CCA is how much? CCA is 80% of your GCA, that is how much? I am getting your 4000 hectare. Now when it comes to Rabi, I can find out the discharge, how discharge will be how much? The area to be irrigated is how much? Intensity of irrigation into what? Into the cultivable command, that is how much? 4000 divided by the duty. Duty is given how much? Duty is given 2000 for Rabi. Okay, so I can just use this. I am getting how much? I am getting 1 meter cube per second for Rabi season. For Rabi season I am getting 1 meter cube per second. Now for Kharif also I can find out that will be equal to, the intensity of irrigation is 0.3, so 0.3 into CCA is this, divided by duty is how much? It is given 900. It is given how much? 900. So when you solve this, you are getting how much? 1.33 meter cube per second. But in this case, these two are of different season, right? It is written Rabi and Kharif separately. The answer will be the maximum one. Answer will be the maximum one. Understood everyone? Understood? Very good. Let us see the next thing. Okay. Now, this question, okay, this is the different question. What is this question and how to solve this question? You see, they are telling that a canal was designed to supply irrigation needs of 900 hectares of land growing rice of 140 days, base period having delta of this. Okay, so we are using a canal for irrigation of what? For growing rice. Very good, and data are given. If the same canal water is used to irrigate wheat now, okay, if the same canal is used to irrigate wheat now with different base period and delta, how much area I can irrigate? Now tell me, we had a canal designed for rice. Now I am using that for wheat. Same canal. So when I say same canal is used, so what will be same, tell me? If I am telling that same canal is used, then what will be same, tell me? Sorry. If I am saying that same canal is used, then what will be same, tell me? Yeah, discharge will be same. So the discharge which was provided for rice, the same discharge will be provided for wheat. And discharge formula is what? Area by duty. Yes. So I can say the area of duty for rice, yes, will be equal to the area by duty for the wheat. Yes. And can I find out the duty for rice? Yes, we know the formula. 8.64. What is the base period for rice? Is given 140 days divided by depth of irrigation is delta, right? And delta is given in centimeter, so I'll convert into meter. Yes, because the units are in such way that base period is in days, the depth of irrigation is in meter, and this will be in your hectare per cubic. Now tell me, what is the duty you are getting for rice? What is the duty you are getting for rice? 8.64 into 140 divided by 1.04. So I am getting a duty of 1163.077. Yes, are you getting this? Are you getting this? Duty? Yes, for the rice. And for the wheat, how much I am getting? For the wheat, I am getting this as 8.64, okay, into 120 divided by 72 centimeter. That is what? 0.72 meter. So it is 8.64 into 120 divided by 0.72. I am getting a value of 1440. 1440. So now you see I equate this area by duty. For rice the area is how much? 900 hectare, right? And duty how much I got? 1163.077. Now area to be irrigated for the wheat I want to find out. And duty is 1440. So from here I can find out the area of wheat or area which can be irrigated using the same canal for wheat. So how much, what is the final answer then, tell me? What is the final answer? Tell me. What is the final answer? Tell me. Good evening. What is the final answer you're getting? Tell me. Taking so much of time today. Yes, 1114.28 hectare. Because this is in hectare, so I'll get the answer in hectare. Any doubt in this type of question? Any doubt in this type of question? No doubts? So whenever they give that we have already designed a canal and now we are using it for another crop, then just equate what? The discharges. Just equate the discharges. Yes. Next thing, okay. This water application efficiency is asked. How to find out water application efficiency? Water application efficiency is the depth of water, it is the depth of water stored in root zone. It's the depth of water stored in root zone. Yes. Divide by what? Divide by how much? Divide by the water applied. Yes. So now you see in this question, 15 meter cube of water is diverted to 35 hectare field for 5 hours. Right? So can I find out the water applied? Yes, I can find water applied. You see, this much discharge is done for 5 hours. So what is the volume? The volume will be 15 into 5. But this is in hours, so convert into seconds. So 60 minutes, 60 seconds. So this much volume of water is applied, right? This much volume of water is applied. So how to find out the depth of water applied? That will be divided by what? The area. 35 hectare means 10 to the power 4. Yes, meter square. So I'll get from here what? The water applied, right? I get the water applied. So how much water applied? 15 into 5 into 60 divided by 35 divided by 10 to the power 4. I'm getting how much? 0.7714, right? Are you getting the same answer? 0.7714 meter. Now, the depth of water stored in the root zone is given to you, 0.4 meter. So from here I can easily find out what? 0.4 divided by 0.7714 into 100. Very straightforward question. So 0.4 divided by 0.7714, okay, into 100 giving me how much? Almost I can say 51.85 or 52% of irrigation efficiency. Right? Next question. Okay. So this is question on what? The intensity of irrigation. Now, intensity of irrigation is what? Intensity of irrigation is the ratio of area irrigated by what? The CCA, right? CCA. Now it is written that in a certain year, 37% and 53% of CCA area in Kharif and Rabi remained without water. Means what? Water is not provided, or I can say irrigation is not done, right? So can I say area irrigated in Kharif season is 63%, na? Yes or no? Tell me. Yes, this is the area irrigated in Kharif season, because when I am saying 37 remained without water, that means what? The rest 63% was provided with water. I can say that much area is irrigated, right? Yes. And in the Rabi, I can say that 47% is irrigated. Yes, 47% is irrigated. Yes. So I can say that this is the intensity of irrigation for Kharif, and this is the intensity of irrigation for the Rabi. Yes, yes, because this much area is irrigated, right? I can say like that. Yes. So they have asked the intensity of irrigation in that entire year. So when they ask you for the entire year, so what you do? The intensity of irrigation for the entire year will be the irrigation intensity in the Rabi plus irrigation intensity in the Kharif. So it will be 63 plus 47, that is equal to 110%. Yes, intensity of irrigation can be more than 100%. Intensity of irrigation can be more than 100% when you are adding all the seasons. When you are adding all the seasons. For a particular season, I can say it will be less than 100, right? For a particular season, it will be less than 100, right? Yes. But if you, like suppose I am telling for Kharif it is 63%, right? And for Rabi it is 47%. For a particular season, the intensity of irrigation has to be less than 100%. But when considering the entire year, for the entire year it can be more than 100. And they ask you for entire year, what do? You find out for Kharif, you find out for Rabi, and then add them up. Okay, very good. Let us see the next question. So these were the questions from, all these were the questions from where? From your water requirement of crops, and we actually solved a lot of questions, right? Covering many aspects which they can ask in the examination. Now let us solve one question from, Lacy design, which they can ask. It's an MSQ question. So multiple things can be correct, and in Lacy you have to remember the formulas, right? So in Lacy we have the silt factor as how much? 1.76 root under the silt size, right? This is the silt size, right? This is what? The silt factor, right? The silt factor formula, because all of these formulas are what? Empirical in nature. Now we should know how to find out the velocity. How to find out the velocity or mean velocity, that is what? Q discharge silt factor square divided by 140 to the power what? 1 by 6. And how we find out the bed slope? The bed slope formula is what? The silt factor to the power 5 by 3 divided by 3340 q to the power 1 by 6. So they have asked, so just tell me using these formulas that which of the options are correct, because it's an MSQ question. It's an MSQ question. So please solve this question. Come on, start. So empirical formula to remember, like you know, another empirical formula is there, right? The weighted perimeter. Obviously that is not asked here, but you have to remember all the empirical formulas, okay, which are connected to your Lacy design. So all these formulas you remember. So but they have asked what? Mean velocity, silt factor and bed slope. So tell me which is the right answer. Come on. The silt size is given, this is silt size and this is discharge, right? Use them. Okay, so see, we're easily able to answer questions from Lacy's design if you just remember the formulas. So when it comes to Lacy's canal design, you have to remember all the formulas, basic formulas. So silt factor you're getting 1.244 actually, so we can say 1.24. Mean velocity you're getting almost this, and bed slope you're getting 1 in 3051 point something, you can say 3052. Yes. So I can say this was, we can say, class on we can covered almost all the most probable question which they can ask from irrigation engineering, yes, in the upcoming GATE examination. Now more questions also I have solved, okay, so you can visit this lecture. I have solved more questions for practice, okay. Here this is the IIT previous year question series for irrigation, so I have solved more than 10 questions here. You can refer to this video, okay, where previous year questions are solved, and along with some new questions I have also solved here, okay. And you see, whenever I give you to see some particular video, if you are unable to find in the channel, just Google it. Google it. You can write down what? IIT Kanpur previous year series irrigation Satyajeet Sahu. If you search it like this, then directly Google also you can get, right? So it will save your time, right? It can save your time. Yes. So this lecture you refer. Also, I have solved lot of questions for a HPCL, BEL and TSPC in hydrology and irrigation. And all these questions can be what? 1 mark questions. See, today most of the questions which we solved are actually 2 mark questions for your GATE, right? So some 1 mark question, theoretical questions if you want to solve, more than 20 plus questions I have solved for irrigation. So total hydrology irrigation I have solved 40 questions. But along irrigation, I have solved more than 20 plus questions, which can be asked in the upcoming GATE exam. So you can refer this video also. Also, there is one topic known as what? The stability of gravity dams, right? Where we study the factor of safety against overturning, against sliding, right? And the uplift pressure, yes. So all those things, we can say have less probability of being asked in the examination, but certainly they can ask, okay? Okay. In the description also, in the description also, what you can do, if you go to the description, there is a smart list. There also you can find all my lectures. There is an Excel file actually. There also you'll find all the lectures. I think, thank you Aftab for reminding me. I just forgot it is there. Thank you Aftab. So I will be sharing the screenshot in the next lecture. So from there also you can find out. Okay. So this is stability analysis of gravity dam. So this lecture also you should refer. Okay, I have explained in details because I cannot explain in details now because limited time frame. So I have explained its lecture in details. So you can see this. Okay, here also I have solved how to find out the various forces, hydrostatic forces, uplift pressure. Okay, uplift pressure they can ask in the examination. Okay, yes, and when drainage gallery is there, how the uplift pressure changes. So all those things I have solved. Okay, and I found out the factor of safety against sliding and overturning. Okay, so thank you very much for your wonderful participation. Yes, so looking forward for more such sessions, and I am available on this channel till 13th of November. Okay, till 13th of November I will be taking lectures on this channel. After this, what will happen? From 13th of November, the BYJU'S GATE ESE Hindi YouTube channel will change to what? BYJU'S Civil Mechanical channel, and there we will be taking what? Both Hindi and English lectures. Okay, so now the bifurcation of the channels is based on languages. Please check WhatsApp. Okay, I will check. Sometimes I'm very busy, so I am unable to check the WhatsApp. So I just keep the phone. I will check this. Last few days was really a little hectic. So I'm not sure. I'll check. Okay. So from 13th of November, what I was telling. Yeah. So we will have the channel bifurcation based on what? Not on based on language, but based on branches. So civil mechanical students, please subscribe to the Hindi channel also. Yes, because that channel will change to civil mechanical and I will be solely available in that channel. So I won't be available here. I will be available in that channel only. But there I will take lectures both in English and Hindi. So both languages we will there. And as you know, it is written that we will have a smart playlist is available in the description. Okay, in the description you can go to the smart playlist that will direct you to a Google Sheet. So there you know all the lectures series wise, okay, and department wise they are mentioned. So you can refer to those lectures whenever you want to see. Okay, so thank you very much. So tomorrow also at 6 p.m. we will be solving questions on highway engineering. So please do join, okay, and hope that this particular lecture help you in clearing many of your concepts for upcoming GATE and ESE examination. Thank you very much. Bye.